Okay. Um, hello, people. Um, yeah, I'm Noah. I'm Noah, the robotics co-head that nobody knows. Yep. And I'm going to talk about computer vision with AI today. Yeah. So let's get started. So this is the agenda for today. So we did the introduction. We're going to talk a little bit about why AI is important. And we're going to talk about, oh, hey, Sterling. Sterling.
Hello,
Hello.
I have arrived at my second robotics club meeting. I'm excited.
Yay!
Yes. All right. Okay, so we're talking about like the agenda. Just like we're going to talk a little about why AI is important. We're talk about the future of computer vision. Talk some theory, as Ben Stumpf would put it. And we're gonna do a sample case study. Like an AI that I was able to get working that can tell if you're wearing a mask or not. So later, you guys can prepare like wearing a mask, and then I'm gonna take a picture, and we're gonna see if it works. And after that, we're gonna talk a little bit about Inspirit AI. That is the course that I'm kind of doing this presentation for, because y'all know I'm not gonna do a presentation on my own. I can't do that. And then we're gonna do a little bit of Q&A. So, all right, let's get started. Okay. All right, we're gonna talk about why AI is important. So AI is all around us. Is in self-driving cars. That's like upcoming. Netflix recommendation systems. That is AI. Kind of language processing in like Siri and Alexa. These are all instances of AI. And you can already see that AI is already part of our life in many ways. So that is why AI education is that much more important. And AI is an interesting field because it can kind of pair with a bunch of different fields. It's like it can affect any field. You can see with the statistics, right? On the left, you can see like the growth in percentage of papers related to different fields. So AI and CS are like skyrocketing. And on the right, you can see also like AI related startups also skyrocketed over the past 20, 25 years. So AI is, a rapidly growing field. Um, yeah. All right. That's it. That's all I'm going to talk about AI, why AI is important. So we're going to actually talk about the future of computer vision specifically now. So computer vision has a lot of applications, right? It's like seeing. Seeing is, can help a lot for us. So it can open like a whole new like doorway for computers. And here's like a list of kind of applications. Self-driving cars, we talked about that. Medical image segmentation, kind of determining if cells are, like kind of if there's like a virus in the cell or not. Like that's you can kind of like see that with computer vision. Face recognition, tracking, like Snapchat filters. Um, AI is, or computer vision is definitely part of that. Augmented reality, right? Kind of like Pokemon Go, right? There's like augmented reality. You can see like Pokemon actually in the world. That's computer vision. You got to determine where to put the Pokemon. Car plate recognition. I mean, I know in Shanghai there's like a lot of parking spaces you can just kind of drive in and it detects your plate and then it kind of like keeps track of how long you're parking. And that's kind of computer vision, kind of like seeing where the car plate is and deciphering what are the letters or what are the numbers and letters on the plate. And really any kind of visual recognition task, computer vision has to be part of it, right? So yeah, so here are some examples of computer vision. On the left, it's AI kind of seeing cars, people, and traffic light. This is kind of the self-driving car kind of example. And on the right, this is really interesting. It's AI kind of transforming real life into animation, or kind of simplifying real life details to make it look more like animation. And let's look at it. So yeah, so this is, like an example of computer vision and some pretty cool things you can do with it. And here is the kind of like visually recognizing the self-driving car, kind of seeing where everything is. Yeah, so you can see it's like identifying everything. All right, how do I go to the next slide? All right, so now to quote our own CS department head, Defense Stump, let's learn the theory behind kind of computer vision technology and AI specifically, the AI side of it. So a convolutional neural network is kind of like one of the best computer vision AI models. And it might look pretty complicated at first, but we're really only going to focus on the feature learning part of it. And feature learning is kind of just, the machine is learning how to know or how to understand images. And that's the feature learning part. And if you look above the feature learning part, I don't know if you can see my mouse or not, but you can see these words, right? These are each layers. And layers are basically kind of like each layer will change or transform the input data in some way. So you can see the input is like an image of a car, right? And then this layer will transform it, hand it to the next layer, transform it, and so on and so forth. And we're actually going to learn about the specific layers, or the kind of like the most prominent layers in a convolutional neural network. You can see convolution plus ReLU and pooling. We're actually going to talk about the convolutional layer. And the convolutional layer is kind of what this convolutional neural network, or CNN, is all about. So let's look at the top left. Imagine this big matrix as an image, right? Because an image is basically pixels, and these pixels have like numbers to represent how colorful they are. So this matrix is then transformed with a filter. And this filter is predetermined. And this filter, the purpose of it is to extract certain features from the image. Let's say, like an edge, or I don't know, like an edge or a curve. These filters are supposed to kind of highlight those. And you see then there's a resulting image, or a resulting kind of matrix. And this is the processed data. And you can see this filter is predefined, but it's not just one. There are a bunch of different filters you can see here. And it goes through each of them one by one to extract different kinds of features. Since each of these is kind of extracting a certain kind. All right. So this is kind of the most important layer. And you can see here, this is the convolutional layer. But what is this ReLU thing? Right. Now, ReLU is pretty funny. It's pretty funny. ReLU is kind of like the simplest part of the neural network. All it's doing is making all the negative numbers to 0. That's it. So everything that goes through this function becomes the minimum is 0, right? So let's say you pass in -5 to the function, it becomes 0. If you pass in 2, it becomes 2. If you pass in -10,000, then 0. That's it. That's the only thing ReLU is doing. It's making sure there are no number below 0 in the data. All right. So let's move on to the next layer. We can actually. Okay. Oh, this is working. All right. So the pooling layer is another very simple layer. The only thing it's doing is making the data smaller. And specifically, I used the max pooling layer. And the max pooling layer, all it's doing is taking the maximum of each quadrant. You can see with this really good visual. And that's it. That's the only thing it's doing. There are average pooling layers, which is kind of like taking the average of each sector and then kind of preserving that data. But that's it. Those are the three main layers that, or the three main parts of the of the convolutional neural networks learning phase or feature learning part. Yeah, so that's it. You can see it's repeating and is continuously condensing the image into more and more data and more different details from the convolutional layer, and that's it. And classification here, classification is kind of the extra part of the network. After at this point, you have a machine that can understand images for a specific task, right? And classification, or the second part, is what you're going to do with that machine. So you can see here, this animation, we're going back to the animation part. This user decided to use this machine that can understand images to simplify this image at specific parts to make it look like an animation. And let's just watch it. This is so nice. And then the second part, and then another part, this is actually classifying what's in the image, right? This is a car, this is a traffic light, this is a truck, a person. These are, and you can see this is like a bad one. This is a house, but it thought it was a bus, right? So this is classification. And what we're going to do later, in the demo is classification. The machine is classifying if you're wearing a mask or not, basically. All right. So let's take a break. I need to set up the actual demo and prepare to be amazed or not. So in the meantime, you can actually, there are some pretty cool sites that kind of visualize. I can't find my Zoom. Where's my Zoom? There are cool websites that kind of visualize how a convolutional neural network is working. I'm gonna drop it in the chat. This model can determine like what number you are drawing, and that's kind of what it's doing. Yeah. Thanks, Slava and Sterling, for coming, and Jimmy. Okay. Yeah. So I'm gonna set up the model now.
This is wild, Noah. The like visualization of it.
Yeah, you can see it's kind of like going, it's condensing it, right? Condensing the details. It's pretty cool.
Very cool.
Fascinating.
All right, so now I kind of have the model ready. For people who want to participate, you can kind of turn on your camera. I'm gonna do, like a big picture. You can wear a mask or not. That's up to you. I'm gonna wear a mask. And then the Zoom mask. Actually, I'm not sure. You can try it out. Try it out. Yeah, we need both sides. We need some wearing masks, some not. Jimmy, you should open your camera and do the Zoom mask. Oh, actually, yeah, okay. I'm not gonna wear my mask. Let's see. All right, is nobody else gonna? Oh, okay. Good. We have 2 and 2. All right, fine. This is good. So, am I sharing my screen? I'm not sharing my screen. Actually, that's good. I'm not sharing my screen. Okay, so I'm gonna take a picture right now. Nice. Okay. So now I can share my screen. Sick. Let's see. Let me try to find it. No. This is not cooperating. All right, let's try this again. All right. Okay. All right, let's see if I can just drag the image. All right, I can. All right, you can see this is the image. So what it should detect is, I actually don't know about the zoom, but it should detect probably 3 people wearing masks and 1 person not. I'm scared. I don't know. Is it even working? Oh, it is. Great. So you can see the green boxes show that you are wearing a mask, and the red box is showing that you're not wearing a mask. And if we can run it again, I'm going to show the confidence value this time. So how confident the machine is that you are wearing or not wearing a mask. We're going to run it through again. And you can see that it's pretty confident. 1.00, that's 100%, 100%, and 100%, 100%. So, it's working pretty well. And that's, through computer vision, they can identify the faces and see if the face is wearing a mask or not. Yeah, that's kind of the demo. All right, let's go back to this. Yeah, all right. So I'm going to talk a little bit about the program now, because it's actually through this program, which is like kind of like a short 10 session, pretty intense. I mean, not really intense. There's no programming experience required. It's just like 2 hours, I think, every week. And, it's a really fun experience. This AI Scholar, sorry, 2 hours like every day for 10 days. That's it. And, you can, no programming experience required, but then you can you go in and then it's some pretty intense, pretty crazy topics to start, right? So I learned about computer vision specifically because like I did like a more deep dive into computer vision. It's like a very project-based assignment or project-based course. And you can see here, this one is actually what I made this model. Well, me and like a group made this model. I'm just gonna say group. Yeah. So a group made this model that can kind of process a video, which is basically a series of images, and kind of determine, as a self-driving car perspective, what are the things actually in the image. And that's Jimmy. I am kind of forced. It's okay. But it is pretty cool though. You can build these stuff, and it's not even 2 hours for like 10 days. You can kind of learn the entire concept more in depth than this, and actually do hands-on work to build these kind of cool models. I think it's pretty cool. So yeah, so if you have any questions, I'm just going to be here for, I don't know, like 15, 20 minutes until people leave. And, any questions about, like the course or the actual concept? Anything, you can just feel free to unmute. And yeah.
Did you design the program that detected the masks or not?
Yeah, I mean, I did, yeah.
Woo!
Oh, I did make it with TensorFlow. Hey, Victor knows. Yeah, TensorFlow is TensorFlow library is a Python library that you can kind of use in Python to build a bunch of pretty cool stuff. I did cheat a little because because the thing is, my part of the model can only identify if an image is wearing a mask or not. But what happens if an image has, like 5 faces? Well, then let's say like 2 of the faces are wearing masks, 2 of the faces are not wearing masks. Then what should my model do? Well, actually, I can actually show you. This is, okay, never mind. I used kind of an extra part, this model, that can detect all of the faces in an image. It's pretty creepy. You can kind of detect where each face is. And then I kind of splice the image to only have that face. And then I use my model to detect if there is a mask or not. So, that's why kind of like programming is so flexible. You can kind of do everything. I'm taking like the outputs of this model and kind of using that as the input of my model. And yeah, TensorFlow does make it very easy to play around with. Especially, yeah, it's like the API or the way you write it is actually really simple. I might be able to show you the whole training process. Let's see if I can find it. I don't know if I can find it. If you see a mask detection, oh, this one. Okay. Okay, if you're like, yeah, all right. So, if you can leave at any time, right? It's okay. We won't hold that against you. So this is the process. All of this is importing the data from like an online source. And this is the data. So you're taking in, so I take in data from here. That's kind of, each image is like kind of like a face. Actually, not this one. It's another one that's more specific. But anyway, it is kind of like this. I take in all these data and then I train it. You can see here, this is one of the examples. I train it in a model, and this is kind of like the structure of the model. I think it's pretty simple. I'm just, I'm kind of cheating again.
So simple, Noah, really so simple.
No,
Yeah, I totally understand it too. Yeah.
Well, look, I'm actually cheating here a little again, because this is exception is actually a pre-trained model from TensorFlow that is really good at the feature learning part of them. At the feature learning part, if we go back, the feature learning part is actually understanding the image. So I basically took the pre-trained model that can understand the image very well, and I took its outputs, which is it's kind of like what it thinks this image is or whatever, and then I classified it based on that. So did I really write this? Did I really make the model? Kind of, not really. I put it together.
No way.
I put it together.
Your coder buddies are listening. You completely created this.
Sure, yes. Completely created this. But I definitely put it together, but I didn't do all the important stuff.
No one, just stop talking. You're making it sound worse every second.
Yeah, okay. Well,
Just
anyway,
give us
that's
the
that.
complete truth. All right, thank you, Noah. I have to head out. That was really, really interesting, and I'm very impressed with your skills. And to the teacher who might creepily be watching this later, give him an A+.
Well, all right. Thank you. Thank you for coming. All right.
Yeah, I thought it was interesting in the model how you sent us that like as it goes up, it gets harder for us to understand, but I think easier for the computer.
Yeah.
And then also, why does the first drawing kind of multiply into 6 and then they just,
Oh, which part? You're talking about the website, right?
yeah.
All right, cool. I can kind of like walk through that one. All right, so let's just draw an image. All right, so each of these is a result of a filter, right? So remember I was talking about the convolutional layer has a bunch of different filters predefined that each extract image. And you can kind of see here, actually you should go to present mode to make it look bigger. You can see each filter kind of results in its own output. And that's kind of what's happening here. That's exactly what's happening here. Each of these filters is a result, each of these outputs is a result of a specific filter. And that's why it looks kind of different, right? And I think this layer between the second and the third is a max pooling, right? It's kind of like pulling the data to kind of extract the features or kind of condense it. And you can see again, I'm pretty sure, again, this is another convolutional layer. Oh, and you can kind of see here. You can see the first layer is a convolutional layer using 6 different filters here. The second one is a downsampling, and downsampling, it's kind of like a pooling layer. It's kind of making it smaller. And the third layer is a convolutional layer. Again, you can see it's splitting into more, as Zach said, it's splitting into more results, each with a different filter. And again, you can see the model actually is almost exactly like how this is going. It's kind of going in a loop, right? It's going convolutional, pooling, convolutional, pooling. And here as well, it's convolutional downsampling, convolutional downsampling. And in the end, the fully connected, that is the classification part. You're kind of like seeing, okay, like the machine understood this image to be this matrix of data, this matrix of numbers, this assortment of numbers. Now, how can I use this assortment of numbers to classify what number is actually written? So you can see this is fully connected because it's really fully connected. Look at all these lines, right? It's kind of like each going to the next layer. Oh, my computer is heating up. Oh, it feels like it's gonna explode. But yeah, you can see this is exactly how the convolutional layer, that neural network is going, is how it's doing its work. It's it's applying the filters, making the data smaller, applying more filters, making data even smaller, and classifying what number it is. So it's pretty cool. I feel like this is a super good visualization. There's one more link I should have posted that I forgot. This is actually, like Victor talked about, this is TensorFlow's kind of visualization of a neural network. And this is more general, like a more general neural network. It's not just for image. You can see it's full of, as we would call it, like fully connected neural network, connected layers that kind of has, strings going through every possible combination. So it's kind of passing data in every possible way to kind of see which are important and to kind of see what is important in this image and what is not. And you kind of play around with this. It gives you a lot of kind of freedom to play around with the structure of this model. But I think this is kind of not as good a visualization as the other one, because this one makes it really clear what is happening through each layer. But yeah, I think this is pretty cool. Let's see if it works.
Yeah, thank you. I'm also gonna go, but this is interesting. Thank you.
No problem. All right.
Noah, are there any flaws to your system thing? Or like there probably is, but you
Yes,
don't know yet. Okay.
there is. Let's do something. Okay, so
What do you
Yeah.
mean, Victor? I was just
All right.
interested.
So let's see if I cover my mouth. Do you think it will identify it as a mask? Let's try it. I wonder if okay. Take a picture. I'm gonna share my screen again here. And I'm gonna go through. Is this still running? It's still running. Okay. Go through with it. How do I? Did I drop it? I don't know. Try it again. Let me just close this and then do this. So what do you guys think? What do you guys think would happen? Right, because it's trained to identify a mask or kind of anything that goes, above the face, right? So what would happen if I put this in? Will it be a mask? Will it be not? Let's actually show the confidence actually. All right, you should, put your guesses in the chat of how confident it is in percentage. How confident it is and how confident it is and what is its like ultimate decision. Am I wearing a mask or not? So I'm guessing. Okay, all right. So I think
Victor, look at us.
Okay. Ready? So I'm gonna submit this. It's gonna take a while. And it says what? Okay, that's interesting. See, this is
Wow.
this is a flaw. This is a flaw caught in 4K. This is 100% confidence that I am wearing a mask.
Wow.
So there is flaws, right?
Wait, is it just because it looks like a mask, or?
I'm not sure. Because yeah, the last
Like,
time I
is
read
it?
it's simple.
Oh.
Yeah, go ahead.
Is it like your machine thing simply judging it based off like all the pictures you've given it, or like I don't
Yeah.
know. I don't know.
So it's kind of identifying common trends within all of the image
Uh-huh.
that I gave it. So, a
I
common
see.
trend is that if I'm wearing a mask, then I have something, covering my mouth, for example.
Mhm.
That's kind of like the kind of details that it catches on with. And this is interesting. Yeah, that means it's not a perfect model. And I don't think any AI model is perfect, but this is very this is very interesting. I wonder how you can improve it, right? Because if you train, let's say if you train it on, or you give it more reference images of people just, kind of like holding their hand over their like mouth and nose, maybe it will start to learn that, okay, this is a special case where having something over your face doesn't work. But then, then there would arise like another problem of, can it identify, kind of like flesh colored masks with hands? And so it's kind of always improving or always needing improvement. So yeah, thanks for pointing this out. This is actually, yeah, I'm really interested in this. What's the next step? What's the next step for the model? All right, but anyways, any other questions? All right, there's like only 3 people, so okay. Yep.
I personally thought that was very cool. Thank you for presenting.
Oh, thank you. Thank you for coming.
Sweet. Oh,
All right.
people are headed out.
Okay.
Bye, Noen. This
right,
has been
see ya.
great.
Thanks.
Yes, no way.
Okay, I'm gonna
Alright.
stop the recording.